Have you ever stopped to ponder the prodigious power of the sun? This luminous ball of energy, at the heart of our solar system, is the life-giving force behind our existence. And yet, how much do we truly understand about the sun and the complex processes that allow it to shine so brightly? The sun, a nearly perfect sphere of hot, ionized gas, primarily composed of hydrogen and helium, is not just a ball of fire. It's a celestial powerhouse, where a fascinating process known as nuclear fusion takes place. This process, occurring at the sun's core, is the sun's secret for its radiant energy. Picture, if you will, 4 individual hydrogen atoms in the sun's core. The tremendous heat and pressure, a result of the sun's enormous gravity, force these atoms to collide and combine. This interaction forms a new particle, a helium atom. But here's the intriguing part. The helium atom is slightly less massive than the combined mass of the 4 hydrogen atoms. Now you may be thinking, where does the missing mass go? Well, according to Einstein's famous equation, E=mc², mass can be converted into energy. And that's exactly what happens. This missing mass is transformed into an incredible amount of energy, which is then emitted as light and heat. This energy, produced by countless such reactions every second, radiates outward from the sun's core, passing through its various layers until it reaches the surface. From there, it is cast into space, bathing our planet in the light and warmth essential for life as we know it. To summarize, the sun, our solar system's central star, is a near-perfect sphere of hot, ionized gas where nuclear fusion occurs. This process, driven by the sun's colossal gravity, converts hydrogen atoms into helium, releasing an immense amount of energy in the form of light and heat. This energy fuels life on Earth, making the sun a fundamental force in our existence. The sun's gravitational pull orchestrates the ballet of celestial bodies, keeping planets, moons, and asteroids in orbit. As a G-type main-sequence star, or yellow dwarf, the sun has been shining for about 4.6 billion years. It is projected to continue its current phase of stable hydrogen fusion for several billion more years before eventually transitioning into a different phase of its life cycle. So, next time you feel the sun's rays caressing your skin, or see its light illuminating the world around you, remember the amazing process of nuclear fusion that makes it all possible. The sun, our celestial powerhouse, is more than just a bright light in the sky. It's the engine of life, an endless source of energy, and a testament to the wonders of the universe.